this on graph paper though, I guess, because
It does kind of.
we need an illustration.
There's no way you're showing it in that distance. No, you don't. That doesn't make a difference.
Okay, I'm looking at number 1. A is at 1, -2. And B is at 3, -2. So we're supposed to list the component form of vector AB. Which by component form, maybe it's basically what we talked about yesterday. It's just writing the vector kind of as two sets of coordinates. So how far is the vector moving in the x direction?
1,
3. How far is it moving in the y direction? 0. So it's just a 3, 0 vector. Now, can we get that answer without graphing it? Was it 4, -2? Whoops, that guy drew it wrong. Sorry to disappoint you, Allison. You forgive me? Okay, anyways, can we get this answer without like drawing everything out?
Yeah.
How do we get it? So yeah, it's like how far is it from 1 to 3? Same thing as 3 minus 1, right? So you just do the x2 minus x1. That gives you how far it's moving in the x coordinate. And y2 minus y1 gives you how far it's moving in the y direction. Okay, easy peasy. But then they ask for the magnitude. You guys remember what they meant by magnitude? This means the length of the vector. It represents how strong the force is. So, well, it's kind of easy here. How do I find this? How long is that? 2. It's a little trickier. We talked about this yesterday. When there's like if this was like a 1, 2 vector, how long is, what's the magnitude of this vector? We talked about it yesterday.
1, 2.
Pythagorean theorem, right? If you go 1 right, 2 up, that makes a little right triangle, so you can use Pythagorean theorem to find the vector length. So that's what we'll be doing for most of these. Although in this case, it's just a straight line, so it's just 2 and 1, 2 and 1. All right. You guys remember the distance formula?
They're going to men's fair. We haven't had one since like the beginning of the year.
I don't believe you. You go to one every day.
We go outside.
I know. We go outside to Mr. Frederick's class, like, almost every day we ask, he'll just, he never told yeah, he's pressure into yes.
Okay, so this is the distance formula. It tells you the distance between 2 points. So you could just use that to find, you could also just do, if you have the vector already, like we kind of already found the distance between the x's and the y's, so you could just do this as well. Anyway, basically it's just the Pythagorean theorem. Okay, that was number 1, right there. Uno. Trace. You loving every minute of it, Ava? Okay, so how far are we going in the x direction? From -3 to -5, how far is that moving?
2.
-2. Okay, and if you get confused, just do x2 minus x1, right? Like that. Alright, so it's -2. And then from -5 to 1, it's going up 6, yeah. Or you can do 1 minus -5. It's +6. Okay, how long? What's the magnitude of the vector? How long is it? Okay, you could do. So this is like a 2, this is like a 6, and we're looking for the length of the vector. It's 2 left, 6 up. So how long is the vector? 2 squared plus 6 squared, and then the square root of that, right?
Yes.
So 2 squared, -2 squared is the same thing as 2 squared, right? You can put parentheses around it. Plus 6 squared, and then you have to, that's equals c squared, so you have to take the square root of that. Okay, yeah, let's go ahead and simplify that. Square root of 40 is 4 times 10, so it's 2 square root of 10. Numero 5. Okay, so this is the other, so that was component form, we talked about that one yesterday. On number 5, we're switching to what they call polar coordinates. My word. So it says, it basically tells you the length of the vector is 6, and then that angle is like how far off the x-axis it is. So that 72 degrees would be like this angle right here. And they want us to change this to component form. Like how far is it moving in the x direction? How far is it moving in the y direction? So how could we do that? Well, if I draw the lines in here, how could I find the x and y components? Right, so yeah, relative to 72 degrees, this is the adjacent and hypotenuse. So that is cosine of 72 equals adjacent over hypotenuse. So to solve for x, we would do cosine 72 times 6. They rounded to the hundredths place, the second decimal place. Yeah, 1.85. I guess they didn't name this, did they? Okay, we'll just put, they said for us to draw it, but that's I guess that's our sketch there. Okay, and then for y is the opposite over hypotenuse. So that would just change it to sine. So it's sine of 72 times 6.
5.71.
Okay, that is going to happen every time. Cosine, because it'll always look something like this. Cosine will give us the x, sine will give us the y. And as I say that, we got 140 on the next one. Yeah, this should still work. So on 6, the picture, it says 140 degrees, but the length is 8. So 140 would be about like that, right? We could use like,
So, 40?
we could use this triangle to figure it out. No, no, just give us the y value. Wait, what am I missing here? This is what we need, yeah, this is the vector right here. Okay, so anyway, if this is 140, what's this one right here gonna be?
40.
We don't really need all this triangle stuff, I shouldn't have drawn that. So, it looks more like this, yeah. So yeah, for the, here's the problem. Should our x value be positive or negative here? Negative. Y value should still be positive. I think it's still, if you plug in cosine of 40, it'll give you a positive, but it still should be cosine of 140. So plug in, what's cosine of 140?
Negative 0.766. And then for cosine of 40, it's 0.766.
What? That can't be the same.
That's what I got.
Okay, what? Tell me what you plugged in again.
Cosine of 40. And it equals 0.766. And then I put cosine.
0.7. Oh, or did you switch to radians?
Probably.
Okay, we actually do need radians on number 7, but not on number 6.
I'm back.
Okay, so just plug in, don't do 40, do the 140. These are basically reference angles here. So what's cosine of 140? Cosine of 140, somebody. Sam's not here, somebody's gonna have to do it.
Negative 0.76.
Okay, what's cosine of 40 then?
Probably gonna be positive.
0.766.
Oh, duh. My bad. My brain is not working. Okay, cosine of 140. Okay, but that should be adjacent over opposite. No, you had it right the first time.
I did.
But what were we doing wrong? Or what did I forget to do, I guess? That equals opposite over, or adjacent over hypotenuse, right? So anyway, you gotta multiply by 8. You have to multiply by 8. Just like last time. Cosine of 140. Ava, did you do cosine of, I'm so confused, why?
Is it
No.
because it's in a partial negative quadrant? Maybe in the second or
No.
negative.
Maybe yours is it.
I had mine in degrees whenever I did that.
Yeah. Okay, I just heard you wrong. I thought you said 7.66. Okay, yeah, that's right. My bad. All that work for nothing. Okay. You could do cosine of 40 times 8 and make it negative, or you could just do cosine of 140 times 8 and it'll already be negative. So that is the answer. So it's negative 6 point, what was it again?
I didn't get a negative on that.
Yeah, it's just 6.1.
Yeah.
Okay, it's either cosine of 40 times 8 and then you make it negative, or you just do cosine of 140.
Negative 6.12.
Okay, when the angle is over 90 degrees, the x coordinate's going to be negative. Okay, so you still do cosine of the angle times the magnitude of the vertex to get the x value, and you still do sine of the angle, all that for nothing, times the magnitude of the vertex to get the y coordinate. So sine of 140 times 8 would also give you the y coordinate. This should come out positive though. Okay. So on 7 it's the same thing, except for what's different about 7. They're in radians, so you have to switch your calculator. So 2 is the length of the vector. Do you guys know where 4 pi over 3 is?
No.
Where is pi?
Isn't it just...
It's over here, yeah. So 4 pi over 3 is like 1 1/3 pi. So it would be like down here somewhere, yeah, a third of the way to 2 pi. So that's what it will look like. It's 2 in length. But it doesn't really matter. You still kind of use the same thing. But you do need to change your calculator to radians. Cosine of 4 pi over 3 should equal x over 2. So you just change it to radians. Do that times 2. For the x coordinate. And this one is for the y coordinate. Bonk. Okay, number 9. When we add two vectors together, what happens to their x and y components? V is negative 8, 4. Okay, this is from yesterday. If we add these two vectors together, what would the new vector be? Yeah, you just add the x coordinates, add the y coordinates, that's the new vector.
5 and 5.
Yeah, very straightforward. So if you do, B says u minus v, so for the x you do 3 minus negative 8, so 11, and 1 minus 4, negative 2. C says 3u plus w, so what would we have to do on that?
Multiply u by 3.
Yeah, triple the lengths on u, so it's 9, 3. Plus, oh, I didn't write w down. W is negative 6, negative 2. So 6 plus negative 6, or 9 3 plus negative 2 is 1. Yeah. D. Okay, D says the same thing as C except for it puts absolute values around it. So what does that mean if it puts absolute values around it?
It has to be positive.
You find
No. Yeah, you find the length of the vector. It's not doesn't mean absolute value, means find the magnitude, the length of the vector. So how long, the length of the vector is 3, 1. 3, 1. So how do we find the length of that vector? Yeah. 3 squared plus 1 squared and then the square root of that. 3 squared plus 1 squared is 10, so it would be the square root of 10, which is going to simplify. Okay, 11A. Same thing. These are kind of easy peasy if I do say so myself. So the 1/2 W, if we multiply the W vector by half, is -3, -1. So U is 3, 1 plus -3, -1 would equal 0, 0. That's the vector going nowhere. They also call it the zero vector. Okay, does nothing. So B says, what is the magnitude of that vector? Zero. The magnitude of the vector going nowhere is 0, as in C. Okay, for C they want us to do the magnitude of U plus the magnitude of 1/2 W. So here's U right here. Here's the 1/2 W right there. So 3 squared plus 1 squared and the square root of that. Yeah, it's 1. We just did that a second ago. -3 squared plus -1 squared and the square root of that. Still 10. Square root of 10 plus square root of 10. 2 square root of 10. So if you find the magnitude of the vectors individually and add them together, it gives you a different answer than adding the vectors together and then finding the magnitude. Because when you add those vectors together, they cancel out. Leo, are you processing any of this? I don't think so.
You're right.
Allison? Okay, I'll try to slow down a little bit.
I guess you know.
Okay.
Watch the first video yesterday.
You didn't? Or,
No.
okay. Well, that would have helped, but do you see where I got, do you know where I got this from? Did you look at number 11A?
Yeah.
Okay, so for the first part, I just copied what they put in the directions. For the second part, I just did half of the other vector. And I added those two together. Okay, yeah, the zero vector thing I did mention yesterday. It's just when the vector is going nowhere. So the length of that vector would be 0. Anyway, okay, 13A. Half of the way from A to B. That one's kind of obvious. Yeah, but 14. Yeah. So 13, what's half of the way from A to B if A is at 0, 0 and B is at 6, 3? Guys, come on now. What's halfway between these two? Oh wait, these are points, not vectors. 0, 0, 6, 3. What's halfway between those two? Okay, midpoint formula, the point that's in the middle of these two, you just average the x's and average the y's. What's halfway between 0 and 6? 3. What's halfway between 0 and 3? 1.5. Oh, I think there's only a 14 is trickier though. We actually have to use our brains. So. Okay. So, the midpoint formula, you guys might remember, it looks like this. You add the x's, divide by 2. You average them. You're averaging the x's. And then you add the y's and divide by 2. If you only want to go... Yeah, that's not going to work for this one. Never mind. Okay, so on 14, here's what they wanted us to do. They wanted us to find the vector from A to B. So A is at 1, 4, and B is at 5, negative 4. So what is vector AB? How far are we moving in the x direction from 1 to 5? How far are we moving in the y direction from 4 to negative 4? Negative 8. 4 is to negative 4 is going down 8. Okay, but we only want to move 1/4 of this vector, right? So we need to multiply this by 1/4, and that new vector would be 1, negative 2. So starting from A, because A is like our starting point, we want to move 1, negative 2. So in other words, we're going to move 1 in the x direction, so 1 plus 1 is 2. And we're going to move negative 2 in the y direction. 4 minus 2 is 2. It'd probably make more sense if I drew a picture, but real quick. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, there's a picture of the vector, AB. A was right there, B is right there. The component form is 4, negative 8. But we only want to go 1/4 of the way along that vector. So, somewhere in there. So you just multiply that by 1/4. We got 1, negative 2. Means we want to move right 1 and down 2 to move 1/4 of the way. So that was at 2, 2. Got it. Alright. Well, I hope you got it because we're about to do it again. 15. So on 15, how far is the A moving, Leo? How far are we moving from A to B on the x direction? On 15, how far are we moving from A to B in the x direction?
The x direction would be 5.
Well, it's going down 5, right?
Down 5, right?
So it's negative 5. Then how far are we moving in the y direction?
Up 10.
Yes. Okay, if you're not sure, just do 8 minus negative 2. Do the second one minus the first one like we did at the beginning. So the vector from A to B is 5, negative 5, 10. It means it's moving left 5 and up 10. But the directions tell us we want to go only 4/5 of that length. So we want to multiply these by 4/5. So we get negative 4, 8. If you multiply both of those. Okay, that's not the answer, that's how far we need to move. Starting from point A. And A is at 7, -2. So if we move left 4, 7 minus 4, that will be at 3, and -2 plus 8 will be at 6. So that gets us to 3, 6. Yoink. Alright.
We'll stop there.
You broke it.
I think it's a good place to stop though.
15.
Wow.
It's a sign. Okay, we only have like 10 minutes. Be good if we could start getting to the problems.
Get a lot done right now.
Dream on, sucker.
We can be really diligent with our time and work.
Like we always do.
What fantasy land are you living in? Okay, Alcin on 17. If you don't know how, I'm going to have to tell you. How do we get from -7 to -1? So if you're not sure, you just do -1 minus -7.
Oh, 6.
It is 6, yeah. So I'm going to call this vector AB. And then how do we get from negative? Yes. Okay, then how far do we want to go? To 3/5 of the way? Oh, this is messy. They weren't nice to us on this one. Okay. Well, I guess I'll just leave it as an improper fraction. If we multiply those by 3/5, that's how far we want to move. I guess, yeah, maybe I could do it without a calculator if I change these to mixed numbers. 18 divided by 5 is 3 with remainder 3. 9 divided by 5 is 1 with remainder 4. So that's how far we want to move. Where are we starting at? We're starting at point A, 3, -2. Basically, we just add that vector onto that point, and that gives us the new point. 3 plus 3 3/5 is 6 3/5. -2 plus 1 4/5. You guys know that
How
one?
did you get the 3 and -2?
3 negative. Oh, was that?
It's on 18.
Oh, that was 18. Oops. 17 is -7, -4. Okay. -7 plus 3 3/5. That's kind of tricky. It's -3 2/5. Yeah, I might have to use your calculator on that. -4 plus 1 4/5 is -2.